Hello everyone, this is Mrinal Kanti Roy Choudhury. The title of the talk is Conditional Quantization. Conditional quantization is another fascinating area of research that has also been introduced jointly by M. Pandey and M. K. Roy Choudhury. Conditional quantization has significant interdisciplinary applications. For example, in radiation therapy of cancer treatment, to find the optimal locations of N centers of radiation, where K centers for some K less than N of radiation are pre-selected, the conditional quantization technique can be used. Conditional quantization has two classifications: conditional constrained quantization and conditional unconstrained quantization. Let me now give you the definition of nth conditional constrained quantization error. Let P be a Borel probability measure on Rk, equipped with a metric D, induced by norm this on Rk. Let R be a positive real number and gamma is any subset of Rk. Write VRP gamma equal to this. Those who are familiar with statistics and probability, they can easily understand that this expression represents a kind of error, which is called variance. Indeed, VRP gamma is called the distortion error for P of order R with respect to the set gamma. Let Sj be a family of closed sets with S1 non-empty and beta be a subset of Rk, and beta is fixed with cardinality of beta equal to L for some positive integer L. Then for a positive integer n which is greater or equal to L, the nth conditional constrained quantization error for P of order R with respect to the family of constraints this and the set beta is defined by this expression. So if you look at this expression, VRP alpha n and beta, these are all errors like this. VRP gamma. Here, beta is fixed and alpha, the elements of alpha comes from the constraint sets with cardinality of alpha less than equal to n minus L. That means cardinality of alpha union beta is less than equal to n. So you calculate all possible errors for defined alpha and same beta. Then you take the infimum. That infimum is called the nth conditional constrained quantization error for P of order R with respect to the family of constraints this and the set beta. A set alpha union beta where alpha comes from the constraint sets and the probability of the Voronoi regions of the elements in beta with respect to the set alpha and beta is positive, for which the infimum in 1 exists and contains no less than L elements and no more than N elements, is called a conditional constrained optimal set of endpoints for P with respect to the family of constraints this and the conditional set beta. Now, conditional constraint quantization dimension and coefficient. Let V and Rp, which are nth conditional constraint quantization error, be still decreasing sequence and write V infinity R P equal to this limit. Of course, this is a non-negative number. Then the number DRP defined by this, if it exists, here R means this R that occurs here. is called the conditional constrained quantization dimension of P of order R. The conditional constrained quantization dimension measures the speed at which the specified measure of the conditional constrained quantization error converges as n tends to infinity. For any kappa greater than 0, the number this n to the power over kappa times v nrp minus v infinity comma rp, if it exists, is called the kappa dimensional conditional constrained quantization coefficient for P of order R. So far you understood what is nth conditional constrained quantization error, conditional constrained optimal set of n points, conditional constrained quantity dimension, and coefficient. Now in unconstrained case, if there is no constraint, that is if all Sj that occurs in this definition are equal to Rk, then the above definitions of nth conditional constrained quantization error, conditional constrained optimal set of n points, conditional constrained quantization dimension, and conditional constrained quantization coefficient reduce to the corresponding definitions in unconstrained scenario. That is, they respectively called as nth conditional unconstrained quantization error, conditional unconstrained optimal set of n points, conditional unconstrained quantization dimension, and conditional unconstrained quantization coefficient. There is an important remark. Conditional unconstrained quantization can also be referred to as conditional quantization. And then, in unconstrained case, nth conditional unconstrained quantization error can be called as nth conditional quantization error. Similarly, conditional optimal set of endpoints, conditional quantization dimension, and conditional quantization coefficient in the case of unconstrained scenario. Here are the references: constraint quantization for probability distributions, constraint quantization for the Cantor distribution, constraint quantization for a uniform distribution with respect to a family of constraints, conditional, constraint, and unconstrained quantization for probability distributions, conditional quantization for uniform distributions on line segments and regular polygons. So these papers are all available in arXiv. Some of them are accepted or published. Thank you all for listening.